Okay, so maybe let's begin. My name is Marcin Żbik. I work in the grid dynamics for over 1.5 years. I'm a DevOps engineer there, and today I will present you the few slides about when Terraform alone is not enough. It might be treated as a sentence. It might be treated as a question. We will see during the presentation. I will show you our journey, but a bit more about this in the agenda. So we will start from the very beginning. What is the Terraform itself? By the way, anyone ever used the Terraform? Okay, good. At least few of you. So later I will show you what were our client requirements and what client expected from the Terraform. And in the main part of the presentation, I will show you our journey with the Terraform, how and why we created the wrapper, and what was the actual journey. I know it won't be that cool as the Hobbit or the Ring team, but well, something. And I will tell you how it ended, because it might be, or maybe not, will be surprising. So, as I said, for the very beginning, let's say a few words about what is the Terraform. Some of you already know it, but there were people who did not raise a hand. So, Terraform is the example of the infrastructure as a code, pretty well useful thing, and in last, I think, year, 2 years, very popular. It can be used to provision, change, and the version infrastructure, what is very handy when you want to have easy reproducible infrastructure. It supports all major cloud providers like AWS, Google Cloud, Azure, Ali Cloud, and etc. It, of course, supports tons of others. I really recommend you to and encourage you to visit the Terraform documentation site, where is the information about what it supports and what it can do more. And it uses HashiCorp configuration language or JSON for infrastructure description. A small disclaimer is that most of the documentation is about the HCL. However, you also can use the JSON, which is well easier for to parse and generate for the programs, computer programs. Maybe not for the human, but still. Okay, so we know what is the Terraform. Now let's speak about the client's requirements about all of this. So client wanted us to help them to migrate their applications to the cloud. At the start, we should create the POC with the one application, and the ultimate goal was to overall migrate more than 100 applications, so plenty of them. The idea was to have one company-wide solution for infrastructure provisioning and application deployments, because currently or previously every team has their own ideas, own way how to create the infrastructure and deploy it, and moreover they were still using the on-prem solution. Moreover, the idea was to create the reusable components and the blocks which can be easily used by other teams to make the deployment and infrastructure provisioning faster and easier. It should be easy to use by everyone, not only by technical people, and this time saying technical, I mean ops, DevOps, and administrators. Developers should be able to use it. I know developers are also technicals, but not that kind of the technicals. And it should be version controlled, just to know who, when, and why changed something in the infrastructure definition. Why we even decide to use the Terraform? It was because, first of all, the Terraform was not only an option we could use. There were plenty of others. More of them were well, paid versions, enterprise, but they were lacking of the features at that time. and there was no license fee required upfront. Okay, if you would like in the future buy the license and have the support, no problem, there's the Terraform Enterprise. However, for the start, you don't have to pay it. We could use it ad hoc, just go to the Terraform site, download, and start using, of course, after reading the documentation. It already supports most of required features we need, and one of them was the Google Cloud Platform, which was the cloud of choice for the client. They decided to use the Google Cloud, and the Google Cloud is really good and was really good supported by the Terraform, so it was another argument for the Terraform. Okay, we took the decision, we know the client requirements, so now we have client's expectations versus the Terraform and the decision why we even thought about creating the wrapper for this Terraform. So after evaluation, we found some issues. One of them was that our client was unable to provision the different environment for the same directory in easy way. And the easy way is the very important thing here, because of course you can deploy more than one environment from this one directory of the Terraform. However, you need to specify the extra argument for the Terraform command. It was, I think, state file argument. But this is not considered as an easy way. So that was the one thing. Other thing was that provisioning of more complex environment was too difficult for non-technical users. And again, the non-technical is the guy who is not in the operation, but more like, I don't know, QA or developer who only cares about doing his stuff or her stuff, not creating the infrastructure. It was not supporting the upfront defined hierarchy of variables files. Client wanted to have the definition of hierarchy of files from which variables would be inherited and overwriting the lower priority variables. So it was not supported by default by the Terraform. And again, of course, you could use the vars file and provide few of them, but it was not upfront defined. And there was a lot of code duplication between components of application and applications itself. Let's imagine that we have few applications. We started with the one, but later it was 2 and 3 and up to 100. A lot of code was duplicated between those applications, which was not that handy for the client and hard to maintain, especially later. So, what was our first attempt? We decided to use plain Terraform configuration files. No fancy templating, just configuration, just Terraform configuration file with the TF extension. And every application was supposed to be self-contained, which will be very important later. And let me explain what does mean that it was self-contained. If application contained web server, database, and message queue, because why not, everything should be defined in one application, one Terraform, maybe not the configuration file, but configuration in many files. However, in one place. Because if you are a QA or developer, you would like to create entire environment only with one command or one button, this holy grail one button deployment. So we decided that the application will be stored in the main repository to make use of these reusable blocks for the other teams. Because if other teams would have the different, every app team would have different repository, then this code duplication will be much bigger. And because of one of the requirements from the client, we introduced the hierarchical structure of the application also to make it more clean. We created the apps directory where there were the application itself directories where Terraform files resided. And at the first attempt, this wrapper took 3 arguments: the application name, the environment name, and obviously the Terraform command, which is, well, required. During this first attempt, this wrapper was really small, really clean. That's why we decided to use the bash for it, because bash is for gluing stuff. And it had less than 50 lines, including empty lines. So it was really simple stuff. At the very beginning, it was more than a year ago. Okay? But it was not enough. We had another attempt. Let's call it modularized attempt. We started to use the Terraform modules because we found that they were useful for us. We could use it to reduce the duplication. Maybe it sounds like an obvious thing, but at the beginning it was not suitable for us. Later, when we understand the Terraform better, we decided that modules will do the job for us. So we started with creating the few modules we found most required. And as I mentioned earlier, the application consists of one or more so-called components. So the web application is one component, this database is another component, and let's say that MQ is another component. And we started to introduce the concept, the idea of immutable infrastructure, because, okay, we are doing the infrastructure as a code. We are trying to migrate client to the cloud. Why not introduce the idea of immutable infrastructure, which seems to be fitting very well to this entire scenario? We introduced also the concept of the environment type. This is what I mentioned, that there should be one company-wide standard. So there should be the QA type of the environment, for example, development and production, non-production, whatever you want. There is the list of this for this particular client. Not that important. The important thing is that there is the idea of environment type. At the same time, we started to introduce the variables and hierarchical variable structure. There is the common variables, where there are most common variables like application name, for example, or the number of the components, or something like that. What is common for each environment type and each environment name. From the top to the bottom, there is the list and the highest priority variables file. And those variables files were nothing more than just the plain text files compatible with TF-vars file format. What does it mean? It means this is more or less key value file, because it was key equals value, sometimes hash map, something like that. And how it ended with that modularized attempt? Well, it ended with about 1,000 lines of the code. There's the scale, so you can compare it. Previously, it was the small screen. Now we have humongous amount of the code. So, well, Bash maybe is not the best solution for this. So, more teams started to use our application, because maybe not the application, our wrapper. More application teams started to use our wrapper. So we decided to introduce one more parameter to our wrapper. It already had 5 or 6. It was the group, because more teams started to use it, and because of this, we should make those directories more clean. So we decided to add the group directory. So there's the application directory, the group of applications, and inside of this group we have the applications itself, because this is how the client structure is created, the application structures. And because of this, we had to introduce new variables file, and the new hierarchy is that we have the common vars in the applications directory, application group common vars in each group application, applications common vars, which is inside the application, and as it was before, environment type and environment name variables. This makes this requirement about hierarchical variables file field. So more applications were added, and because of this, more and more teams started to use it, which resulted in more and more folders added or directories added to the repository. Obviously, because every application has its own directory, it makes them more and more, which started to become harder to maintain. What we did, we introduced the Jinja 2 to reduce code duplication. This is, I think, most of you know that this is the templating engine for the Python. And because we introduced the Jinja 2, we had to use the Python, which is good for the DevOps stuff, at least in my opinion. So we moved part of the bash code to Python 2.7. Why 2.7, you might ask? Because client uses the Red Hat Enterprise Linux. So, well, it does not handle very well with the Python 3. At least we thought that. You can't, at least you can't install the Python 3 as the main interpreter. Okay, that's why we use the Python 2.7, not the Python 3. And more application teams means more requirements. What a surprise. So, different teams, different requirements, because nobody wants to change their habits. Each new team or every new team created a couple new options in the module. So imagine that we started with small, sleeky module with 5 options, and we ended with the same module, but having 30 options. It's really hard to maintain such thing, and kind of useless, because the only team which will use part of those options will be only your team, not other teams, which is, well, strange. And not that reusable. We found that some features are in Google Cloud Provider are missing, so we decided to at least create the issue in the GitHub of the Terraform or Google Cloud Provider, or we decided to write it by ourselves and, of course, push it to the upstream to the GitHub repository. And the very important thing, application teams started to require orchestration features. What does it mean? It means that in our example, we have the example application, which consists of MQ, database, and web server, just a reminder. And this web server required the database, and the database required MQ because of some reasons, but not the instance of it. I mean, not the VM or container, whatever, but the application itself being ready to serve the traffic. So this is the orchestration feature on the higher level, not only on the infrastructure level. And as I said, requirements started to grow rapidly. Teams started to ask us for the complex disk size calculations, file system management, which is definitely not a part of the infrastructure provisioning. They started to ask us to support the different disk options, more or one or more additional disk or zero disk, HDD or SSD, local SSD, which is a special version of the SSD for the Google Cloud. And they would like to easily disable each component per provisioning, which is not that simple in just simple Terraform, because conditionals in the Terraform are not that obvious. Okay, you can do the count equals 0 and it will be like false, but well, 1 or 2 such conditions, okay, more codes become complex. And last but not least, the client would like to have the integration with their custom proprietary DNS solution, which required from us to write custom, well, because the custom solution, custom Python scripts which were executed manually or semi-manually by our Terraform provisioner, not provider this time, but provisioner. And because all of this, there were first misunderstandings. As I mentioned about the orchestration, this is not the part of infrastructure provisioning. However, teams do not understand this. They demand this. They desire this even. So teams started to create custom, impossible to reuse modules, at least by other teams. They could reuse it, but other teams not really, because it was very, very specific to this particular team. And let me remind you that we have 100 applications. Let's assume that 3-4 applications are maintained by one team, so we have more than 20 teams. And the very annoying thing was that the different approach, every team had a different approach for the environment naming. For example, one team was naming the environment production and the development, while for the other team, the non-production means the development. So there is no non-production. And it was one of the ideas to have the company-wide standard. How it ended? We heard that they create a wrapper for our wrapper for the Terraform. Okay. And the applications started to be not self-contained. This is the what happened when teams started to require the orchestration. They created, instead of one self-contained application, they started to create 3 applications, which consist of one component of the application. So create the MQ first, wait more or less manually or with the Jenkins for the MQ ready to serve the traffic, then execute another step for the database with the Jenkins or some other automation tool, and later the web server, which was, well, not our idea at the very beginning. We wanted really to have one self-contained application with different components. Not everyone liked it, it looks like. Okay, so what we tried to do, because you can try, not always it works. The first thing you can do, or at least try to do, is to educate and explain how to use, because maybe the reason why they demanded this orchestration was because they do not understand how it should be used or what was our idea about this entire solution. So we tried to educate and explain how it should be used, but you know, nobody wants to change their habits. Some teams required some extra features, and we found out that they were reasonable, and we decided to implement this. But remember, it was 1,000 lines of a code in the bash, so adding new features in the bash, it makes things even more complex. And we try to explain how to fix the applications to not require the orchestration feature, which seems to be the most desired one. How it ended? It ended with the wrapper 2.0, because we have one wrapper, it kind of failed, so write another wrapper. Maybe this one will be better. We had that experience, this new requirements. After a year of using by other teams, we knew what they would like to have. At least we thought we know. So we started from scratch. This time we decided to use pure Python free code because it was possible to use this Python free at last in the Red Hat Enterprise Linux. So we decided to use, and finally Python 2.7 is end of life. Maybe, maybe not. We'll see in 2 years. And because we like to have test coverage, we decided to have almost or as close as possible to 100% test coverage for the code. Maybe we could have better test cases, but the test coverage at that time is 98% because we cannot find the easy way to test few parts of the code. This time, the Jinja 2 was used as a template for entire Terraform configuration file. So this time, we are doing all conditionals, all logic inside the Jinja, not in the Terraform files. As a result, we have static Terraform files with as small amount of variables as possible. If something can be set as a static, let's do this. And because all of this, it becomes much more flexible. Each team can use it however they want to use it. If they have very specific requirements, please go ahead, use it. You can do this with our new version of the Terraform wrapper. But because of the flexibility, it becomes more complex to use it, of course. We use the YAML file, and when the previous version of the wrapper at the latest stage required 5 to 6 lines, maybe 10, okay, to have the definition of the component, now we required entire YAML file, for example, with, I don't know, 50 or 60 lines of the definition. As I said, flexibility, but it costed because of the complexity. And we decided to support only what Terraform supports natively, like this, the DNS solution, which was really painful for us because it was really custom solution. And those extra scripts later during the provisioning. So support only what is supported by Terraform. You want your custom solution? Okay, write the support for Terraform. Later we can just use it because it will be supported by Terraform. So there is the POC of the run of this Terraform 2.0, and there are more or less results because we are still waiting for the evaluation. There were almost 4K lines of the code in the Python, okay, including the code, but the tests, sorry, but still, in my opinion, for the wrapper, it's a lot of lines of the code. However, of course, application teams were not happy about the behavior and usage changes because first time in this presentation, nobody likes to change the habits. They get used to the previous version, the version, let's say, call it 1.0, and we changed entirely the way how they use it and how create, let's call it blueprints for a moment. So totally breaking the backward compatibility, and we did it for the reason was not a good argument for them to use the new version. And this time it looks like it's too flexible because of those two big files. It started to compete with in the complexity of just Terraform. Because when you compare the Terraform with this YAML, okay, maybe YAML is easier to read, but the amount of code you need to write is similar. And there were plenty of new usage patterns we did not expect during designing sessions. Well, new team, new requirements. There were few requirements we did not, expect during the design session. We could not expect everything. So, what's next? As I said, as I mentioned, we are still waiting for the proof of concept evaluation by applications team. And, well, usefulness of this wrapper is, questionable. Very different requirements for different teams. And we already found some bugs to fix. But, okay, this is the code. We are not perfect. Everyone makes mistakes in the code, and it was a bit buggy. We already fixed that, but, okay. So, as I said, we are still waiting for the evaluation, but I do not have high hopes for this. And because of this, we are leaning to educate how to use Terraform alone, because maybe it is enough to use it alone. Because creating some custom wrappers create the new layer of the complexity. Maybe this complexity at the beginning looks promising, but at the end, it creates more well, complexity, more problems than it is worth. So maybe just use this Terraform alone, because learning curve for the Terraform is not that steep, and later it will pay back you with good results. And well, this is the end of this journey, and if you have any questions, I will try to answer. Okay? Okay, so the question is about how we are storing the shared Terraform states. It's pretty easy, because Terraform now supports plenty of them natively in the open source version. At least in 0.11, 0.10, you can store your Terraform state in the Google Cloud platform, in AWS S3 for sure, even in the HashiCorp console if you would like. At least few of them, and even more GCP, AWS, console, and something more I do not remember now. They support locking. So in case you start doing the changes, someone else would receive the information about locked state. So, and this is called the search for the Terraform state backends. It should help you. Okay. Yes. With the education. Okay, so maybe I will repeat the question. How did we solve the orchestration problem? As I said, we tried to educate. We tried to show other teams how to change their application, change the startup scripts to be able to try more than once or even more than twice to start and wait for this dependency, not just fail and I will do nothing. Sorry. So at the end, there was another feature I did not mention during this presentation. We created an Ansible module for our Terraform wrapper. And from the Ansible level, you could use this wrapper and ask this application if it is ready to serve the traffic. If it is, then go further with the application deployment. That was some kind of workaround for this orchestration solution. The better solution we did not found yet. Does it answer your question or not really? Okay, thanks. Anyone else? Go ahead. Create resource before deployment, something like that. Okay, question about zero downtime deployment. It really depends on the cloud provider. You are using which cloud provider, if I can ask? Azure, okay. I have absolutely no experience with Azure, but in the Google Cloud, theoretically, it works that way that you can expect from the Terraform to do so-called rolling update. It will, at least in the managed groups, there will be added a new template for the instances, and they will be replaced. So you could treat it as a zero downtime deployment, or this create before this deployment or something like that. I do not remember, but I think you get the idea. But we never use that thing. We use this rolling update. So I don't think so I answered your question. Anyone else? No one? Okay. So if you would have any question, I will be on our grid dynamics stand. It's on the first floor, I think, near the stairs, so you can catch me and we can talk. And for now, thank you very much for attending this presentation, and I hope I give you some ideas how not or how to use the Terraform. Thank you.